Hello children, today's our topic is Heron's Formula. We are familiar with the shape of many closed plane figures such as square, rectangle, right triangles, equilateral triangles and scalene triangle. But in this section we shall find the area of some triangles, and we are already familiar with the areas of a triangle as 1/2 of base into altitude. We use this formula when the base of a triangle is given and altitude of a triangle is given. So we shall draw a triangle here. Let us take a triangle ABC. This is A, B and C. And BC is the base of a triangle, and this triangle has a perpendicular, let it be AD, is the perpendicular. So this one is a triangle in which base is BC and the perpendicular or height is equal to AD. For this type of a triangle, we use the formula 1/2 of base into altitude. So we can write in first one, area of a triangle ABC is equal to 1/2 of base is BC side and altitude is AD side. So this is the basic formula for finding the area of a triangle when the base of a triangle is given and altitude of a triangle is also given. Now this formula is also used for an equilateral triangle. In an equilateral triangle we know that all three sides of a triangle are equal. Consider an equilateral triangle here. First of all we draw an equilateral triangle with sides. All sides are equal. Let it be A, B, C is an equilateral triangle. Second one, with all sides are equal, let the all sides of an equilateral triangle be A unitus, and A unitus. So second one is an equilateral triangle. Area of equilateral triangle ABC with side. So this one is an in triangle. ABC, AB is equal to BC is equal to CA, both are equals to A unitus. So now in this equilateral triangle we can use this formula as well, 1/2 of base into altitude. But the three sides of a triangle is given, so we have to draw the altitude of this triangle. So draw AM perpendicular on one side of this equilateral triangle from the vertex A, perpendicular on the side BC, this side BC. We draw this altitude, name it as AM is a perpendicular on this side. And we know that in an equilateral triangle, altitude divides an equilateral triangle, divides the base of an equilateral triangle into two equal parts. That means this BC, BM is equal to CM is equal to 1/2 of BC, but the length of the BC is equal to A, that equals to A. So that means the side of a length BM is now equals to A by 2. This one is also equals to CM, A divided by 2. Now consider a triangle, right angle triangle ABM. ABM is a right angle triangle in which the hypotenuse is given. This AB is the hypotenuse and base is also given, that equals to BM is equal to A divided by 2. In any right angle triangle we use Pythagoras theorem. Why we use Pythagoras theorem here? To find the altitude or height of this triangle. So consider a triangle ABM using Pythagoras theorem by PGT. By Pythagoras theorem, hypotenuse square is here AB, that equals to A square is equal to base square is equal to A by 2 whole square. This is base square plus altitude square. Altitude is here AM square. So first of all, we can find the altitude of this equilateral triangle, that is AM. So this one equals to A square is equal to A square, A by 2 ka whole square. When we put the square on both numerator and the denominator, we get A square divided by 4 plus AM square. This is AM square. So we transpose this A square by 4 to the left hand side. So we transport these A square by 4 to the left hand side. We get here this one. So A square minus A square divided by 4 is equal to AM square. AM square. That means we can transpose here multiplication is 4A square minus A square divided by 4 is equivalent to AM square. But 4A square minus A square is equal to 3 times A square divided by 4, that equals to the altitude AM whole square. Now we have to find out the altitude of a right triangle, that is AM. So here AM is the square, here we can transpose this square as well. That means we can write AM is equal to square root of 3A square divided by 4. So AM square is equal to 3 square root of 3A divided by 2. This is the altitude of an equilateral triangle. AM is equal to square root 3A divided by 2. Now after finding the altitude of an equilateral triangle, we can use this formula, that is 1/2 of base into altitude. So for equilateral triangle, the base was BC, that equals to A units, and altitude is AM, that equals to square root 3A divided by 2. Therefore, area of an equilateral triangle can be written as, so area of an equilateral triangle is equal to, area of an equilateral triangle can be written as this one, area of an equilateral triangle ABC is equal to 1/2 of base. The base is equal to BC, that equals to A units, and the altitude is AM, that equals to square root of 3A divided by 2. After finding this one, we can write it as 1 by 2 into 2 is 1 divided by 4, or we can write 4 divided by square root 3 divided by 4 into side square, that is square root 3 divided by 4 into A is A square, is the area of an equilateral triangle when it is base is given and the altitude is given. Then the next type of a triangle is an isosceles triangle. When we have an isosceles triangle, and we know that in an isosceles triangle, two sides of a triangle are equal. Let us draw an isosceles triangle here to find the area of an isosceles triangle by using the above formula, that is 1/2 of base into altitude. Now third case is an isosceles triangle. When we have an isosceles triangle, it is supposed that ABC is an isosceles triangle, and we take this isosceles triangle with equal sides. If two sides are equal in the isosceles triangle, let the two sides equal sides be equals to 5 centimeter each. This is 5 centimeter each, and the base BC is equal to 8 centimeter. This one. Now we have to find out the area of this isosceles triangle by using the formula 1/2 of base into altitude. Same, we draw the altitude of this triangle ABC from vertex A on side BC, and this altitude be here AM. This altitude also divide the base of an isosceles triangle BC into two equal parts. That means this BM is equal to CM, both are equals to 4 centimeter. So ABC is an isosceles triangle. ABC is an isosceles triangle. Is an isosceles triangle AB, in which AB equals to AC, both are equals to 5 centimeters, and BC is equal to 8 centimeter. Now we draw the perpendicular here. Draw AM perpendicular on side BC. Clearly this perpendicular divides the base of an isosceles triangle into two equal parts. That means therefore ABM is equal to CM, both are equals to 1/2 of 8, that equals to 4 centimeter each. So the length of a BM is now 4, length of CM is also equals to 4. Now again consider a right triangle, that is ABM. In this right angle triangle, we have hypotenuse AB, it is given. We have base BM, it is also 4 centimeter. Now by using Pythagoras theorem to find out the altitude, means AM of this triangle, then after finding the altitude of an equilateral, this isosceles triangle, we use the formula 1/2 of base into altitude. So by PGT, hypotenuse square, here by Pythagoras theorem, hypotenuse is 5 square is equal to, base is 4 square and altitude is same, AM square. So when we transpose this, 5 square we know that it is 25, 4 square we know that it is equal to 16. When we transpose this 4 square, that is 16, to the left hand side, we get 25 minus 16 is equal to AM square. That means AM is equal to, this AM is equal to 60, 25 minus 16, that equals to 9. So 9 is the square of 3. So AM is equal to 3 centimeter. Then the height of this triangle ABC is equal to 3 centimeter here. So this one is the 3 centimeter height. Now after finding the height, we can use this formula, that is 1/2 of base into altitude, to find the area of an equilateral triangle. Now area of this triangle is equal to area of the isosceles triangle ABC is equal to same formula 1/2 into base. Base is here complete line segment, that is BC, that is 8, and the altitude which we have to find here AM, that equals to 3. So this one is 3 centimeter, 3 square centimeter, because it is an area. That means, so 2 into this, 2 into 4, that means 4 into 3 is equal to 12 square centimeter is the area of an equilateral triangle. So 1/2 of base into altitude is used for the triangle when it is base and perpendicular is given. For an equilateral triangle, we draw the perpendicular by using the Pythagoras theorem, finding the altitude of a triangle. Then after that, we use the 1/2 of base into altitude formula. And same for an isosceles triangle, we draw the altitude, finding the, by PG, using PGT, finding the height of this triangle. Then after finding the height of a triangle, using the same formula, 1/2 of base into altitude, that is equal to 1/2 of base is altitude, equals to the 12 square centimeter. Now the cases here arise for the scalene triangle. For scalene triangle, when we have a triangle, and we know that a scalene triangle is a triangle when 3 sides of a triangle are different, when 3 sides of a triangle are not equal. So for this triangle, scalene triangle, if the length of a side is given but its height is not given. So for scalene triangle, we draw a scalene triangle here, taking their different sides as, so let us draw a scalene triangle with different sides. Take a triangle ABC, is a triangle ABC, is a scalene triangle with different sides. Let the sides of this triangle be A units, this one be B units, this one be C units. When the 3 sides of a triangle are given, but its height is not given. So for finding the area of this type of a triangle, when the height is not given, but the 3 sides of a triangle are given, we take the help of the Herons formula to find out the area of such triangle. Now steps for finding the area of a triangle by using this Herons formula is, first of all, 3 sides of a triangle are given. So first of all, we find the semi-perimeter of a triangle, and we know that perimeter of a triangle is equal to sum of the all sides of a triangle. But semi-perimeter means sum of all sides of a triangle divided by 2. For example, we have a triangle ABC. It is a scalene triangle. Height is not given. So in this triangle, we use Heron's formula. The steps required for finding the Heron area of a triangle by using the Heron's formula is, first of all, we find the semi-perimeter of this triangle. So semi-perimeter, S is written by the letter S is equal to, means semi-perimeter. Semi-perimeter means sum of all sides divided by 2. What are the 3 sides of the triangle? Clearly it is A, it is B, it is C. So semi-perimeter means A plus B plus C divided by 2, means semi-perimeter. Then after finding the semi-perimeter, then we can find the values of, second step, we can find the values of s minus a comma s minus b, and s minus c. Then after finding the semi-perimeter and s minus a, s minus b, and s minus c, then we apply the formula that is known as Heron's formula. That is, third one is area of a triangle is equal to ABC is equal to, by using Heron's formula, that is square root of s into s minus a into s minus b into s minus c, where s is called semi-perimeter and a where s is semi-perimeter, where s is semi-perimeter, and a comma b and c are the sides of triangle, or the sides of a triangle. So Heron's formula is used when all the three sides of a triangle are known, and this formula is applicable for all triangles provided their three sides are given. When three sides of a triangle are given, it will be the right angle triangle. When we have a right angle triangle, its three sides are given, we can use this formula. When we have an equilateral triangle, its three sides are also given, we can use this formula. When we have an isosceles triangle whose two sides are same and one side is different, so we use this formula as well. So Heron's formula is applicable for all triangles when three sides of a triangle are given. Now let us take some examples from your NCERT book, chapter number 12, exercise 12.1. The first question is a traffic signal board indicating school ahead. A traffic signal board indicating school ahead is an equilateral triangle. Look, we have an equilateral triangle and we know that sides of an equilateral triangle are equal. That means the side is given here that equals to A. Then find the area of the signal board, that is, find the area of an equilateral triangle by using Heron's formula. So what is Heron's formula? It is square root s into s minus a, s minus b, s minus c. What is to required? Finding the semi-perimeter of an equilateral triangle. So let us draw an equilateral triangle for this question, and after that find the perimeter. If its perimeter is 180 centimeter, what will be the area of the signal board? This is question number 1 of exercise 12.1 from your textbook. Question is, again I repeat the question, a traffic signal board indicating school ahead is an equilateral triangle with side a centimeter. Let us draw this equilateral triangle. So this one be an equilateral triangle with all sides equal. Is an equilateral triangle. Let it be A, B, and C. In this triangle we have a message, school ahead. The all sides of this equilateral triangle are A unitus, and A unitus. Then we have to find out the area of this equilateral triangle by using Heron's formula. So in equilateral triangle we can write question number 1 here. In triangle ABC. What is this triangle ABC? It is an equilateral triangle with all sides equal to A unitus. Therefore S equals to, for finding the area by using Heron's formula, first of all we find the semi-perimeter of the triangle. The semi-perimeter is denoted by the letter S. S is equal to sum of all sides. What are the three sides? It is A, and A. So we add all the three. It is A plus A divided by 2 is the semi-perimeter. Clearly, these are all like terms. A plus A is 3 times A divided by 2 is the semi-perimeter of this triangle. After finding the semi-perimeter, we find S minus A according to the formula, S minus B and S minus C. Therefore, what is S minus A? That equals to S means semi-perimeter, it is 3A divided by 2, minus A means any one side of the triangle, that is all equals to A. After calculating, you get it is A divided by 2. Similarly, S minus B is equal to 3a, because s is here. 3a by 2 minus b means other side of the triangle, but we know that all sides of the triangle are equal. It is a. Again, it will be equals to a divided by 2. Then again, s minus c is equal to same 3a divided by 2 minus the third side, that is also equals to a, that equals to also a divided by 2. Now we have here s, that is 3a by 2. We have s minus a, s minus b, and s minus c. Now by Heron's formula, we can find out the area of this equilateral triangle. By Heron's formula, area of a triangle ABC, but the triangle is equilateral. It equals to square root of s into s minus a. What is s? So it is 3a, this is s, 3a by 2 into s minus a. What is s minus a? The value is a by 2. It is a divided by 2. The another one is s minus b. The value is also a by 2. The value is another s minus c, that is a divided by 2. So in class 8th you have studied how to pair in a square root and take them out from the square root. So we make the groups here, pair of the equal numbers, equal digits. Therefore, that equals to here, area of an equilateral triangle can be written as this is a divided by 2, one pair. This is a divided by 2, another pair. So taking out from the square root, we get a divided by 2 into a divided by 2, but square root 3. When you multiple, you get a into a is a square. So we can write it as square root 3 divided by 2 into 2 is 4. A square is the area of an equilateral triangle when all sides are equals to a square. Now switch to the second part of this question. If the perimeter is 180 centimeter, what will be the area of this signal board? Now the second part of this question is the perimeter of this triangle is given. What is perimeter? Perimeter means sum of all sides. The sum of all sides is given here, that equals to 180 centimeter. So for second part, we can write here the perimeter of the triangle means sum of all three sides of a triangle. That means perimeter now, for second part, perimeter equals to, perimeter is equal to 180 centimeter. But we know that perimeter means sum of all sides of a triangle. Sum of all sides means it is a plus a plus a. After sum, we get a plus a plus a is 3a is equal to 180 centimeter. That means first of all, we should have to find out the side of this equilateral triangle. That is a is equal to 180. We get transposed to right hand side to 3. So we get 180 divided by 3, that equals to 60 centimeter. Now what is the side of this equilateral triangle? Clearly it is 60 centimeter. Now what will be the area? We have a general formula for this, that is square root 3 by 4 into side square means a square. Now put a is equal to 60 centimeter. In this one, you get the area of an equilateral triangle. Now, therefore, area of an equilateral triangle ABC is equal to square root of 3 divided by 4 into side square means into a square. But what is the value of a? It is 60 centimeter. So we can use 60 here, 60 centimeter whole square. When you give the square of the 60 and centimeter as well, we get it is square root of 3 divided by 4 into 3600 centimeter square. Then after cancellation, we get here 4 1 or 4, 4 900 or. So what will be the area of this square, this equilateral triangle? It is 900 centimeter, square root 3 centimeter square be the area of this equilateral triangle. Now let us take another example from your textbook, that is find the area of a triangle. Example number 4 or question number 4. Find the area of a triangle such that of which 18 centimeter is one side, 10 centimeter is one side, and the perimeter is also given. That means we have a triangle in which only two sides are given and perimeter is given. But Heron's formula is used when all the three sides of a triangle are given. So first of all, we should know the third side of this triangle. So first of all, we draw the diagram of this question. So this is an example number 4. This is example or question number 4. We have a triangle in which two sides are given. The sides are 18 centimeter and 10 centimeter. Let the triangle be ABC. This is A, B, C. Any two sides are given that equals to 18 centimeter and 10 centimeter. Let this one be 18 centimeter and this one be 10 centimeter. But the perimeter of this triangle is given that equals to 42 centimeter. We can write here for question number 4, sides of a triangle are, two sides of a triangle are 18 centimeter and 10 centimeter. So first of all, we should find the third side. Let the third side be, third side be equals to x centimeter. So let this one be x centimeter. Now, according to question, the perimeter of this triangle is given that equals to 42 meter. Now perimeter is equal to 42 centimeter. What is perimeter of a triangle? Clearly all sides sum. That means perimeter equals to sum of all sides. All sides is 18 centimeter. Then plus 10 centimeter. Then plus third side is x centimeter. The sum is equal to 42. Then 18 plus 10, that equals to 28. That means we get x centimeter is equal to, this is 42 and this one is 28. This is 42 centimeter. This is centimeter here, minus 18 plus 10 is 28 centimeter. So 42 minus 10, clearly that equals to 14 centimeter. So x is equal to, third side is equal to, x is equal to 14 centimeter. Means the third side is equal to 14 centimeter. Now for this triangle, we know all three sides of a triangle. Then finding the semi-perimeter of the triangle and using the Heron's formula. Now what is the semi-perimeter of this triangle? Now S is equal to sum of all sides or perimeter divided by 2. What is perimeter here? Perimeter is given that equals to 42. So perimeter is 42. S means perimeter divided by 2. That equals to 21 is the semi-perimeter of this triangle. Now after finding the semi-perimeter, we can find S minus A, S minus B and S minus C. Now here, what is S minus A? Means 42, semi-perimeter is 21. Minus A means one side, that is 18, that equals to 3 centimeter. Then S minus B is equal to 21 minus third side, that is 10 centimeter. So 21 minus 10 is 11 centimeter is S minus B. Then S minus C is equal to 21 minus C. C is the third side, that is 14 centimeter. That equals to 21 centimeter minus 14 centimeter is 7 centimeter. Now after finding the semi-perimeter and S minus A, S minus B and S minus C, now apply the formula, that is Heron's formula. Area of a triangle is equal to square root of S into S minus A. What is S here? S is 21 into S minus A. S minus A is 3 into S minus B, that equals to 11. S minus C, that equals to 7. Square unit is then area of a triangle. Here we can use the pairs, we can make the pairs in the square root number, that equals to, we have it is square root 3 into 7, that is 21 is 3 into 7 or 7 into 3 into 3 into 11 into 7. Clearly 7 and 7 is in pairs and 3 are in pairs. So we take it out from this square root and get the area of this equilateral triangle. So the area of this triangle will be equals to, area of a triangle is equal to square root. So 7 is making pair here, so it is 7 into 3, 7 into 3 into square root of 11. Square unit is or square centimeter. That means 7 into 3 is 21, square root of 11 centimeter square is the area of a triangle. So when we have a triangle, it is two sides are given and the perimeter are given, then we can find the third side. Then after finding the third side, we use the Heron's formula to find the area of this triangle. Now let us take another example, that is sides of a triangle are in the ratio. Now we have the triangle whose sides are in the ratio 12 is to 17 is to 25 and perimeter is given 40 centimeter. Find the area of this triangle. So first of all, we draw a triangle, or let us suppose that ABC is a triangle. So in this question, that is question number 4-5, we have the sides of a triangle are in the ratio. The sides of a triangle are in the ratios are given. The ratios are, this is question number 5, let the sides of a triangle be, the ratios is here, that is 12 is to 7 is to 25. It is 12x, comma 17x and 25x, because they are in the ratios, so we put here an unknown variable, that is x. So all the three sides of a triangle are now given. It is 12x, 17x and 25x. Now for finding the semi-perimeter, so S is equal to, S means sum of all sides divided by 2 or perimeter divided by 2. But in question, the perimeter of the triangle is given, that is 540 centimeter. So we can here 5 perimeter sum of all sides is S is equal to 540 divided by 2. When you multiply it or cross we cancellation it, we get it 270 centimeter is the semi-perimeter of this triangle. Now first of all, we find the exact measures of the sides of a triangle. So perimeter is equal to sum of all sides. It is given 540. Perimeter means sum of all sides, means the first side is 12 centimeter, 12x centimeter plus another is 17x, then third one is 25x. The sum of all the three is equal to 540 centimeters. When we add the two, we get 17 plus 12x plus 25x, we get the sum is equal to 54x. That implies it is 54x is equivalent to 540. So for finding the value of x, we transpose this 54 to the right hand side. We get it is 540 divided by 54. That equals to 10 centimeter. So 10 units is the value of x. Now after finding the value of x, we can find the sides of a triangle. Now the sides are here. Now sides are, first one is 12x, that equals to 12 into x, x is equal to 10, that equals to 120 centimeter. This one. Now second side is 17x, that is 17 into 10, that equals to 170 centimeter. Then third side is 25x, that equals to 25 into 10 is equivalent to 250 centimeter. Now we know the exact measure of all sides of a triangle, that is 120 centimeter, 170 centimeter and 250 centimeter. Now for finding the area of this triangle, first of all we find the area, the value of S. We have already done it here. S is equal to 270 centimeter. Now S minus A is equal to, S means 270 minus 270 centimeter minus A means any side of the triangle, that equals to 120 centimeter. It is 120 centimeter. Then S minus A is equal to 270 minus 120 is equal to 0. Then 725 and 150 centimeter is S minus A. Then S minus B is equal to 270 minus other side, that is 270 centimeter minus other side is equal to 170 centimeter. The result equals to 270 minus 170 is equal to 100 centimeter. Then after finding S minus B, then S minus C is equivalent to, S minus C is 250 minus 250, this is 270 minus 250. S is here 270 centimeter minus C, third side of the triangle, is 250 centimeter. Then 270 minus 250 is equal to 20 centimeter. Now after finding the value of S and S minus A, S minus B, S minus C, put all these value in the formula. The formula is square root S into S minus A, S minus B and S minus C. So the area of this triangle B equals to square root of S into S minus A, this is area of a triangle, is equal to square root of S into S minus A. What is the value of S? It equals to 270 into S minus A. The value of S minus A is 150. The value of S minus B is 100 centimeter and S minus C is 20 centimeter. So after finding this is square centimeter is the area of this triangle. After calculating the values, you get the area of a triangle equals to square root of, after finding the square values of square root S into S minus A, S minus B, S minus C, we can find here it is 9000 centimeter square is the value of this triangle, that is sides are in the ratio 12 is to 17 is to 25. Now let us move to the next question, that will be question number 1 of exercise 12.1. So 12.1 and this Heron's formula is also applicable when we have a quadrilateral. Quadrilateral, it is applicable only when we have a triangle, but if we have a given quadrilateral, we can join one of its diagonal and it into two triangles. Then after division of two triangles, we use the Heron's formula. Let us take an example, that is exercise 12.2, question number 1. So example number 1, exercise 12.2. A park in the shape of a quadrilateral ABCD has angle C equals to 90 degree and AB equals to 9 centimeter, BC is equal to 12 centimeter and DC is equal to 5 centimeter and AD equals to 8 centimeter. First of all, we draw the figure of the given question. The figure is like that. We have a quadrilateral which is in the shape of a quadrilateral whose one angle is equal to 90 degrees. Let this one be a quadrilateral. Let it be A here, B, this is here A, this is quadrilateral C, this is right angled at C. Right angle means the angle C is equal to 90 degrees. This is A here, this one is B, this one is C. So this is a quadrilateral which is in the shape of a right triangle, angle C is equal to 90 degree, in which the sides of this park is given. AD is equal to 8 centimeter. A, B, C, D, this is C here and this one is D here. So ABCD is a quadrilateral in which angle C is equal to 90 degrees. The sides of this park are given. 8 centimeter is AD, this is 8 centimeter. Then CD is also given, that is 5, sorry it is in meters, 8 meter, 5 meter and other side is 12 meter. This BC side is 12 meter and AB side is equal to 9 meter. As we know that Heron's formula is applicable for triangles when the three sides of a triangle are given. But here we have a quadrilateral, not the triangle. So first of all, we should divide this quadrilateral into two triangles by joining one of its diagonal. Here we join the diagonal BD. That diagonal BD divides the quadrilateral ABCD into two triangles. One triangle is ABD, another triangle is BCD. But here we have a triangle BCD. What is this triangle? It is a right angle triangle. Right angle at C. This one is a right angle triangle at C, and we know that when we have a right angle triangle whose base is given that is 12 centimeter and the altitude is also equal to 5 meter, we can use the formula that is 1/2 of base into altitude. So this triangle BCD can be used by this 1/2 of base into altitude. But what about the triangle A, B and D whose only two sides are given, third side is not given? Again consider a triangle, right triangle BCD. This diagonal is the side of a triangle ABD as well as the hypotenuse of a triangle BCD. For finding the third side of the triangle BABD, we use Pythagoras theorem. So first of all, we have to find out the area of this arc ABCD. We can write here question number 1. It is exercise 12.2. The question is we have to find out the area of this quadrilateral ABCD. So in triangle BCD, clearly this is a right angle triangle. We can use the formula 1/2 of base into altitude. So area of this BCD is equal to 1/2 of, which side is here base? Clearly it is 12 meter. It is 12 meter into height, that equals to 5 meter. So after calculating, you get the value is equal to 2,1R, 2,6R. That is 2,6 into 5 is 30 meter square is the area of this triangle ABC and D. Now we have to find out the area of a triangle ABD. After finding ABD, we add the two triangular parts, areas of two triangular parts, and get the area of A, B, C and D. But in this ABD triangle, we have only two sides given, that is 8 meter and 9 meter. To find this third side BD, we take this triangle BCD by applying the Pythagoras theorem, finding the other side, then after that finding the area of this particular triangle by using the Heron's formula. So again in triangle, again BCD by Pythagoras theorem. Why we use Pythagoras theorem? Because it is a right angle triangle. So by PGT, what is hypotenuse? Clearly it is BD square. Hypotenuse square is equal to base, that equals to 12 square. This is 12 meter square plus altitude, that equals to 5 meter square. That implies BD square is equal to 12 square is equal to 144 meter square, and 5 square equals to 25 square. This is 25 meter square. Then after adding 144 to 25, we get 169. What is the perfect square of 169? It is 13. So BD square is equal to 13 square. That means meter square or meter, this one is 13 meter square. Then what is BD? BD is equal to 13 meter. Now BD is the side of a triangle BAD. That means this BD is equal to 13 meter now. Now in this triangle, we have now all three sides. AB is 8, AB is 8, AB is 9, AD is 8, and BD equals to 13 meter. Now we have three sides of the triangle given. We use Heron's formula for finding the area of this triangle. What is the area of a triangle BCD? It is 30 meter square. Now we can find the area of a triangle BCD by using the Heron's formula. So we take this triangle as, so this is in triangle ABD. S is equal to, S means sum of all sides divided by 2. What are the all sides? It is 8 meter plus 9 meter plus 13 meter divided by 2, that equals 2. So this is 8 plus 9 is 17. 17 plus 13 is 30 meter divided by 2, that equals to 15 is the semi-perimeter of this triangle. Now after finding the semi-perimeter, we can find the S minus A, S minus B and S minus C. Now S minus A, this is S minus A. So what is S? It is 15. Minus A means any side of the triangle, that is 8. What is 15 minus 8? That equals to 7 meter is S minus A. Then S minus B, that equals to 15 minus the other side, that equals to 13. That implies 15 minus 13 is 2 meter is the second S minus B. Then third one is S minus C, that equals to 15 minus C is third side, that is equal to 9. So 15 minus 9 is, so then we have 15 minus 9 is equal to 6 meter. Then we have S minus A, S minus B and S minus C. After finding the semi-perimeter and S minus A, S minus B and S minus C, we use Heron's formula to find the area of this triangle. Now area of a triangle or area of triangle A, B, D is equal to square root of S into S minus A. What is S? It is 15 into S minus A, that is 7 into S minus B into 2, S minus C into 3, 6 square meter square. Then it is 15, we can write it as 3 into 5. This is 6, we can write it as 3 into 2. That implies it is square root of 15 can be written as 3 into 5. 7 is 7, 2 is 2. 6 can be written as 3 into 2 or 2 into 3 meter square. Here we observe that 3 is in pairs and 2 is in pairs. So we take out it from the square root, we get here, it is square root of, it is 3 and 2, that is 3 into 2 square root of, this is 5 into 7, that equals to 35. So we get here 6 into square root 35 meter square is the area of this one. Now after finding the value of a root 35, we observe that root 35 is 5.91. This is equal to all, it equals to 6 into 5.91 meter square is the area of a triangle. Then when we multiple 6 into 5 into 9.1, we get the area equals to 35.46. That equals to, when you multiple, you get 35.46 meter square is the area of this triangle. This is 35 plus 35.46 meter square. Then what will be the area of the whole park? It is divided into two triangles. First of all, we find the area of this triangle and this triangle. So find the area of this whole park, that equals to area of a triangle ABCD and area of a triangle ABD. So area of ABCD is equal to 30 plus 35.46. So area of park equals to, now the area of a park equals to sum of the areas of two triangles, that is area of ABCD is equal to the area of a triangle BCD, that equals to 30 meter square plus area of a triangle ABD, that is 35.46 meter square. Then after finding the sum, we get 30 plus 35 is 65.46 meter square is the area of this triangle. Thank you for listening to this video lesson.